Here I am going to explain multiple LEDs on from left to right and off from left to right. Here consider four LEDs. Four LEDs. Four LEDs. This for 1, 2, 3, and 4. Four LEDs. LED 1, LED 2, 3, 4. From that Ardunio board, we have to select 4 pins for 4 LEDs. 13, 12, 11, and 10. These are the 4 digital pins. In sketches, we have to define these pins, digital pins, by using pin mode function. This one is a cathode. This one is anode. Have to made some ground connection of the connection on the breadboard from the Arduino board. This is the ground. Here we use black. Here ground connection is created. All the cathodes of these 4 LEDs connected to ground. This one is first LED cathode is connected to ground. Next to second LED cathode is connected to ground. This is the third LED. Cathode is connected to ground. This is the fourth LED. Cathode is connected to ground. Next, anode of the LED is connected to digital pins of the Arduino UNO through 220 ohms resistance. Here we use 200 ohms or 220 ohms resistance. Here we use 20 ohms resistance. Here also 220 ohms resistance. Here 220. Ohms resistance changes all the 220. Therefore, connections are completed. Here, connections are completed. Consider 4 LEDs. The 4 LEDs cathodes are connected to ground. You have to make the ground connectivity and the breadboard from ground of the Arduino UNO. Anodes of these 4 LEDs are connected to digital pins, 4 digital pins of that Arduino board through 220 ohm resistors. These 4 pins are 13, 12, 11. These 4 pins are 13, 12, 11, and 10. These are the 4 pins. Our aim is multiple LEDs on from left to right and off from left to right. See this code here. This is the code. I erase all these things. Consider 4 digital pins. Okay, now I will concentrate on code. This is the code related to multiple LEDs. Here multiple LEDs. Here generally we use for wide setup. In that wide setup, two curly brackets are there. For the wide setup, 4 LEDs. Next, generally we use pin mode, 13 pin output. Next, pin mode. Next, consider the 4 pins. 12th pin is output pin. Next, pin mode. 11th pin is the output pin. 11th pin is the output pin. Like that, and 10th pin also acts as a output pin, digital pin. These digital pins are connected to cathodes, not cathodes, anodes of the LED through resistor. Instead of writing all these 4 statements, another one is the pin mode. Next, 10 output. Instead of writing all these written all these 4 statements, for using for loop, simply write instead of writing all these 4 by using a for loop, define these digital pins. Okay, coming to this one, for I is equal to wide setup, curly bracket open. For I is equal to 13, I greater than or equal to 10, I minus. Again, a curly bracket is open. Pin mode I comma output. Here I value is initially I value is 13. 13 is greater than 10. Go increment decrement the 13 value. Next I value is 13 minus 1 means 12. The 12 is greater than or equal to 10. Again decrement that value. I value is 11. 11 is greater than 10. Again decrement that I value from 11 to 10. I is equal to 10. 10 is equal to 10. Therefore, here pin mode is equal to I output. Here I value is from 13 to 10. I value is from 13 to 20. I is equal to 13, I is equal to 12, I is equal to 11, I is equal to 10. In that way, instead of 4 functions, we use 2 functions only, for loop function and pin mode I comma output. One important point here is integer I. Integer declaration is very important. Integer I. Next step is our aim is multiple LEDs on from left to right and off from left to right. Left to right means first LED is connected to 13th pin. Second LED is connected to 13th digital pin, 12 digital pin of the Ardunio board. Third LED is connected to 11th. Fourth LED is connected to 10, 11, 12, 13. 10, 11, 12, 13. That is 13, 12, 11, 10. Okay. Initially for I is in wide loop function for I is equal to 13, I greater than or equal to 10, I minus. Digital write I high. That means the LED is on. Delays the 3000 milliseconds. Here For I is equal to 30, initially I is equal to 30. I is equal to 13. I greater than or equal to 10. I minus minus. Again, I value changed from 13, 12, 11, 10. In that case, the LED is on condition. I is high. Delay is 3000 seconds. Therefore, multiple LEDs on from left to right. Left to right means from 13 to 10. And off from left to right. Again, we use for loop for I is equal to 13. 13 to 10 means from left to right. I greater than or equal to 10. I minus minus. Therefore, I value change, decremented from 13 to 12, 12 to 11, 11 to 10. And digital right, I low. Delays 300 milliseconds. Okay. Start simulation. Here LED is on from left to right with delay of 3000 milliseconds and off from left to right only and off from left to right and off from left to right with the delay of 3000 milliseconds. Here, if you want to change the delay in that code, instead of 3000, we use 300 milliseconds. We will see what happened here. Start simulation. The multiple LEDs on from left to right with a delay of 300 milliseconds. That means 0.3 seconds. Okay. Now, multiple LEDs on from left to right and off from right to left. We will see next off from right to left. Right to left. Right to left. Right to left means here the fourth LED is connected to 10th one. The fourth LED is connected to 10th, ninth one. Here first one is connected to 13, second one is connected to 12, third one is connected to 11, fourth one is connected to 10, 13, 12, 11, 10. Now here we use this statement for I is equal to 10 on from 13 to 11, 13 to 10, off from 10 to 13. That is the reason here high value is from 10. High value is from 10. I greater than or equal to I less than or equal to 13. I plus plus. Suppose I is equal to 10. 10 less than or equal to 13. Therefore incremented I value 10 to 11. 11 less than or equal to 13. 11 to 12. 12 less than or equal to 13. Okay. Next one. 10, 11, 12 and 13. 13 is equal to 13 and stop this one. At that instant, digital write I is low with a delay of 300 milliseconds. Here by using this statement, LED is on from left to right. Left to right. LED is on from left to right by using this one. By using this statement. By using this statement, LED is off from right to left. This one is left to right and right to left. Simulate and see the action. Start simulation. LED is on from left to right, off from we'll clearly visible here. We use some delay 3000 milliseconds. 3000 milliseconds. Okay, start simulation. LED is on, multiple LEDs on from left to right. First LED is on, second LED is on, third LED is on with delay 3000 milliseconds, fourth LED is on. Off from right to left. First from right to left, first LED off, second LED off, the third LED is off, also off, fourth LED is also off. By changing these ones, next coming to now next step is multiple LEDs on from right to left. Here right to left. Right to left. And off from right to left. And off from right to left. And here we use this one. Has no meaning. Simply copy this one. Copy and paste here. Paste here. Multiple LEDs on from right to left means right to left. Right to left means 10 to 10, 11, 12, 13. That means on. By using this for loop, we have to create this type of action, and off from and also off from right to left. Off from right to left again 10, 11, 12, 13. By using this one and this one. Here we use digital right high. High mean high. The LEDs are high from right to left and low from right to left. By using this one, now we will see this one. Start simulation. First LED is right to left, right to left, right to left. And also off from right to left. Off from left to left. Here change this one, delay. Here delay and the start simulation. First LED is from right to left. First LED is on, second LED is on, third LED is on, and the fourth LED is on. First LED is off. Delay is very less, therefore action is very fast. Delay is more. Suppose here 3000. Here we use 3000. Start simulation. Multiple LEDs on from right to left and off from left to left. One more important action here is multiple LEDs on from right to left and off from left to right. from left to right. Left to right. Left to right means here the statements are placed in front of two slant lines. Remove this one and start simulation. From right to left, the LEDs are on, shown in figure. And the from left to right, the LEDs are off. Just simply changing these for loop instructions, how to create 4 types of actions. Multiple LEDs on from left to right, off from left to right. Multiple LEDs are on from right to left, off from right to left. Multiple LEDs are on from left to right, off from right to left. Multiple LEDs are on from right to left and off from left to right. Okay. 4 actions are completed.